The sample space is all undergraduate students enrolled at UC campuses in 2016. You can see that the information about the sample space is presented both in graph format and in paragraph in sentences. For instance, you can see that the number 77 appears both ways. As a sentence, it is described as representing among students who reported having experienced homelessness, so not in the entire sample space, only among this subset, so this is a conditional probability. 77% also reported having experienced food insecurity. That means that in this subset, so given that we are looking at those who have experienced homelessness, the probability of also reporting food insecurity is 77%. Notice that the wording says 77% also reported. This is often being confused as indicating that this might be a joint probability of both things. Instead, what it describes is the formula for a conditional probability. Remember that the probability of B given A is the joint probability of both A and B divided by the probability of the condition, probability of A. This is exactly translated by this sentence. Now, in the graph, we also see that that value 77% represents one of three bars that are in dark gray, where we are told that the dark gray represents food insecurity. So we are measuring the extent of food insecurity, and we see that this is done across three groups. So one overall, so in the entire sample space. So this would be simply P of food insecurity, 44%. Compared with relative to just those who have not experienced homelessness. So P of food insecurity given not homelessness, 42%, versus just among those who have experienced homelessness. So P of food insecurity given homelessness, 77%. Likewise, we can see that the next graph represents in light gray by the height of the bar is the extent of homelessness for each of three groups, the entire sample space, all undergrads, versus just those who are food secure, so have not experienced food insecurity, versus those who have experienced food insecurity. So 5% is P of homelessness, 2% is P of homelessness given that the student has no experience of food insecurity, so not food insecure, food secure. And 9% is P of homelessness given experience of food insecurity. Going back to the sentences, you can see that the value 77 is contrasted with the value 42, so those 2% being the probability of experiencing food insecurity, either just among those who have not experienced homelessness or just among those who have experienced homelessness. Likewise, we are told that about 9% of undergraduate students who reported experiencing food insecurity. So you have to have experienced food insecurity for this number to apply to you. So this is our condition. And so in this group, 9% also reporting having been homeless. So this is P of homelessness given experience of food insecurity. And we are told that this value is 4 percentage points higher than for the entire sample space, the value 5% shown in the right side graph. It might help to display all those probabilities. We have so much information that we have numerous options. You can have a tree diagram where you start with food insecurity as the first branch, so as general probabilities. And then in the second set of branches, you would have the conditional probabilities of homelessness given food insecurity. Or you can actually draw the opposite graph where you start with food insecurity as the general branching out of the sample space. And then the second set of branches would have the probabilities that are conditioned on that homelessness. Now, we are asked, in 2016, what was the probability that a randomly selected UC undergrad had experienced both food insecurity and homelessness at some point in the past 12 months? Notice that unlike the other values that were cited in paragraph format, we are looking for an experience with both types of insecurities, food and homelessness, not for any subgroup, but for all UC undergraduate students in 2016. So this is a general probability that includes two events. So this is called a joint probability, probability of Fi and H. And again, because we have so much information here, there's more than one way we can approach that. The first thing we need to realize is that it would be a mistake to simply multiply the general probability, the overall probability of food insecurity, by the overall probability of homelessness. Why is that? Well, the graphs clearly show that the proportion of students who experience food insecurity depends on whether they have not experienced homelessness, whether they have experienced homelessness, or if we don't know anything about that. This is visible by the fact that we have 3 bars of different heights. Likewise, the probability of experiencing homelessness depends on whether we know the status, the food security status of those students. So here, we cannot use the simplified multiplication rule for independent events. We have to use the general multiplication rule for any events. And so we can calculate this either by saying that overall, 44% of students had experienced food insecurity, and 9% of those had also experienced homelessness. So 0.44 times 0.09. Or we could also say that overall, 5% of students had experienced homelessness, and 77% of them had also experienced food insecurity. So 0.05 times 0.77. Either way, we get the same answer up to, obviously, rounding error, since those are all nice, neat whole percents, that give us an answer of 4%. So 4% of all undergrads in UC in 2016 had experienced at some point in the past 12 months both food insecurity and homelessness.